So let's just start with operating system. What is system softwares? System software are those software which actually help hardware to run smoothly and to make this hardware available to user in a way that user should not feel any complexity while dealing with the hardware. Operating system is part of the system software. So understanding of how an operating system can maximize the use of resources. This is just theory topics. Describe the way in which the user interface hides the complexities of hardware from the user. This is again theory. So understanding of the processor management. Let's start from there. Processor management. The word multitasking means that your processor has got this ability to hold so many programs in computer's memory, not just to hold them, but to get them executed as well. But to get them executed as well. In a way that user feels that all of these programs are concurrently in parallel are being executed. You get that? Multitasking is what? We are holding up on so many programs in computer's memory. We are not just holding up, we are executing those programs in parallel as well. Achha, working in parallel is just an illusion. Working in parallel is an illusion. It does not work in parallel. I told you that all of the topics except parallel processing consider that you have one processor. So we are actually dealing with the same phenomena. Even if I've got one single processor, operating system like Windows, it still make you feel that you are having so many programs working together. They are not working together. So what's happening? It is called processor management. That is what is happening. So the concept of multitasking I tried explaining. When it comes to the program, there are so many terms that we use. Job, process, thread, software, whatever. They may have different feelings beyond A level, but for you, they are all the same. If they call several jobs, same. Several threads, same. Several processes, same. Whatever it is a distinct set of instruction that requires its place and time over microprocessor to get executed. Whether it is the whole soul program or it is a part of the program or whatever, don't care about it. For us, it is a separate unit of number of instructions which need processor to get executed. So what happens, what we are studying is processor management. This is one of the tasks carried out by the operating system, processor management. It happens what happens is all the jobs when they enter the system. What does it mean a job is entering the system? It means a program is being invoked. A program is being asked to get loaded so that it could be executed. When a job is entering the system, it is obviously going where? It is being loaded. Being loaded means it is going to the main memory. Main memory. So we say that job is entering the system. And their jobs are queued. Why they get queued? Because there are so many jobs. When they get queued, there are policy applied which, according to the priority of the job, there are policies applied which, according to the priority of the job, decides that which job will go to the microprocessor. While the jobs are loaded, queued, and prioritized, they are waiting for their turn to get executed. They are waiting for their turn to get executed. Whatever the job that comes first in the queue will go for execution. While the jobs are here, hello, leave it. So while the jobs are waiting, they are in ready state. When the job goes to the microprocessor, it is in running state. While the job is in running state and another job arrives in the queue which is having higher priority than the job which is being executed, this job, though it is not yet completed, will be called back to the queue or the ready state. If the job is not called back while it is being executed and it is finished, it will exit the system. It will exit the system. So all the jobs which are entering would go to ready state. All the jobs which are exiting the system can only exit from the running state. Since there are so many jobs in the ready state, these are all queued. But there is one job at running state all the time. If the job is not complete and we have another job that has higher priority in the queue which has just arrived, the job, incomplete job which is being executed will be called back. Will be called back. And if the job gets completed, it will exit the system. Few of the jobs like input output job. Let's say that you have asked Microsoft Word to print 200 pages. The printer that you have, let's say, print 10 pages a minute. 200 pages means 20 minutes. For those 20 minutes, that job will be occupying one space in the ready queue and will also be wasting time in the running state. The foremost and the most glorious task of the operating system is to make microprocessors use in a way that it does not leave microprocessor idle at any given moment of the time. What is the most important job of operating system is to utilize microprocessor all the times and do not leave it sit idle. So this job is actually occupying one space which is actually waiting for IO, provided the speed and the time of computer which is doing billions and billions of instructions. Okay. This is actually taking up space here. And when obviously if it is taking up space here, it means that this job would have some sort of priority. According to that priority, this job will arrive to running state. And in running state, it has nothing to do because it is waiting for its printer to finish the printing. It is wasting space here, time here, and space there. Such jobs which are space in running state, blocked state, will be sent out to blocked state, and they will remain blocked until their IO input output is finished. Once input output is finished, they will be called back at the ready state. They would not go back to the running state. To enter the running state, the job has to be in the ready state. All right. So get the idea? Whenever a new job, a process, a task, a program, a thread, whatever you call it, they all are the same for your syllabus. Enter the system, they go to the ready state. In ready state, they are prioritized and queued as per their priority. When their chance comes, they go to the running state. If there is another high priority job arrives, they go call back, although they are not finished. And if they are finished while being executed, they exit the state, running state. And if these jobs are the jobs which are actually waiting for their input output to be completed, they are sent out to the blocked state, and from blocked state they go to ready state once their work is completed. When this happens, every time the job requires to move on to different states, there is an interrupt. If a job likes to move from ready state to running state, there would be an interrupt. All right, dividend. So for everything there is an interrupt. Without interrupt, nothing happens in computer because processor can do only one task. So if you want processor to do something else, you have to interrupt it. This whole thing is divided into 3 levels. This whole thing is done by the part of the program, part of the operating system, which is called scheduling. Scheduling is an executive. Such small operating system programs which are helping it to perform several jobs are called operating system executives. What do we call them? Operating system executives. This is one of the executives. But it has got further 3 parts in it: high level scheduler, medium level scheduler, and low level scheduler. So the job of high level scheduler is to arrange the jobs in ready queue. When jobs arrive in ready queue, these jobs as per their priority are set in the queue. And for your understanding, there are several queues. There are several queues, and every queue would have a different priority scheme attached to it. We call it policy. This is the job of high level scheduler. When the job comes back, it is still high level scheduler which defines that where the job which is coming back will be placed in the priority list or the queue. When job moves between states, they are moved between states using low level. High level and low level are part of the syllabus, and medium level is loosely coupled. I don't know, once I saw a question which was referring to medium level, but medium clearly given in syllabus. So what medium level does? There are certain jobs which are not doing IO, but they are not doing anything. For example, let's say कि आपने Microsoft Word को load कर लिया, but you are busy doing Facebooking. What's Word doing? Nothing. It is not inputting, it is not outputting, it is doing nothing, it is just sitting idle. In that event, if operating system requires more space, low level, medium level scheduler takes such jobs which are sitting idle, wasting time here, doing nothing, and it actually sends them out to the storage. And when these jobs are required back, this medium level scheduler calls them back. So all the jobs which are dead, not yet doing anything, will be sent out to the storage, and when they are required, let's say that you called back Microsoft Word and now you are working with it, these will be called back to the ready. Is it understood? So these are states. Now, end scheduling. What scheduler does? It loads, it prioritizes, sends out, moves job between states, and moves the job between the memory and storage and all. Now let's talk about just high level scheduler. Let's talk about high level scheduler. So when the job gets to the system, when the job gets to the system, according to some objectives, criteria, and policies, they get prioritized. What are the objectives of scheduling? Do not let user wait for the job to get executed. This is one of the objectives. Objectives are always vague. If a job works one day, fine. Objective is to make sure that that job at that given moment every day works fine. Not to get choked up in the event when there are so many jobs loaded in the system. These are objectives. These objectives are met using criterias. There are so many criteria. Number one, this is an input output bound job, or this is a processor bound job. This is one of the criteria. IO bound or processor bound. A job which is made to calculate so many things together, let's say sales stats, it is processor bound because it would be using less input output and more strain would be over the processor. Whereas a job that requires all your paper to be printed is IO bound. It is not processor bound, it is input output bound. A job that is taking input from user is IO bound because it is using less of the processor and more of the input out. Then second criteria might be if the job is real time or batch processing. Do we need to process the data as soon as it is entered, or we need to gather the data and we process it later at some given time? Most utilized resources. If the job has utilized so many resources, just keep it and let other jobs use those resources. Time required. If the job requires less time and another job requires a lot of time, what is time in terms of jobs execution? It is the number of instruction. Less number of instruction require less time to get executed, and high number of instruction require more time to get executed. So there might be several criteria. Then these criteria are achieved using policies. Policies are actually computer software implementations. Computer software implementations. We call them algorithms as well. Scheduling algorithm. If question appears that what are scheduling algorithms, तो हम उसको बोलेंगे कि वो policies की बात कर रहा है. Now there are two types of policies. What we are talking about high level scheduler and how actually this scheduler prioritize the jobs so that the job in the front may go to the running state. There are two types of policies. Preemptive. What does that mean, preemptive? Emptying means leaving processor. Preemptive means that a job before finishing itself, before getting done, before completing execution, is leaving the processor. So preemptive, going back, waiting for it turn. When it turns come, it comes and completes rest of the execution. It may happen in several turns, not necessarily in one turn. So this is preemptive, a job that may leave the processor before getting done. The other one is non-preemptive. Once it reaches to the processor, it would not leave it until it is finished. You get that? So there are so many. First one is first come, first serve. As the name suggests, it is non-preemptive. If it reaches to the processor, it will finish and then it will get out. It would not come back. This is first come, first serve. Second is shortest job first. Shortest job first means what? This is like a school assembly. All those with shorter heights stand in front. We have been doing it all over. है ना? छोटे छोटे बच्चे आगे खड़े हो जाते हैं और लंबे लंबे सबसे पीछे होते हैं. सबसे पीछे वाला सबसे लंबा होता है. And everyone can see assembly proceedings, isn't it? So that is shortest job first. But when the shortest job first, it is preemptive. Let's say if a job is that short, as in the front of this, goes to running state, and there is another job which is yet shorter, arrives to ready state, this job will be called back. When the job in shortest job first policy comes back to the ready queue, it would not go to the front. It would rather go at the end of the line, as it happens in the school assembly. If you are later than the assembly time starts, you will be asked to stand in the end. You will be standing at the end of the queue. So if the job is entering to the system for the very first time, it will be adjusted as per its size in terms of number of instructions. Once it reaches to the running state, and for some reason if it is called back, it would not get to the front. It will rather get to the end of the line, as I stated over here. This is micro symbol, microprocessor. Do not use this symbol in exam. Rather write the complete word micro, M-I-C-R-O. All right. So in shortest job first, when the job goes to microprocessor, when it gets back to the end. Then round robin. No matter how big the job is, how short the job is, every job is given same amount of time. Let's say if this is 1 minute and 5 jobs, so 60 divided by 5 becomes what? How many seconds per job? 12. Okay? No matter how big or how short the job is. While doing 12 seconds per job, another job arrives. Now there are 6. Then the time allocated to each job will be reduced down to 10. And if there are 5 jobs, one job is done. Now there are 4 jobs. So instead of 12 seconds, 15 will now be allocated to each job. Get the idea? This is round robin. And then shortest remaining time. Shortest remaining time is having 50% the same as shortest job first. So when the job arrives to the system, it is sent to its number as per its size. What is different? When the job comes back, again, as per its size, it is adjusted in the line. Now think about this. Let's say if a job has got 2 million instructions, and while the job was being executed here, 1 million instructions got executed. What remains? 1 million instructions. While the job was being sent for the very first time, system knew that the job has got 2 million instructions. Another job arrived that has 1.5 million instructions. So to the system, the newer job that has arrived has got less number of instructions than the job which is in the running state. 1.5 million call this job back and send 1.5 million job. When the job comes back, it is the whole queue is reshuffled. And since the job has now just 1 million instructions left, it would come to the front. Even that 1.5 million new job will go to the back at the second. So this type of shortest remaining time policy is actually called biased, because the job that was just called back would go back to the running state and keep going back and forth. Even the newer jobs are arriving which are of the shorter size. So what is the difference between shortage of first and shortest remaining time? That shortage of first job when comes back, they both are preemptive. When the job comes back in shortest job first, it goes to the end and queue is not shuffled. In shortest remaining time, when the job enters to the system or coming back from the running state, in both cases the queue is shuffled and the job is adjusted as per its size. So the job which is coming back, if its size is reduced, it will get to the front end. Okay? And same job, there are always chances that the same job would go back to the running state. Is it clear? Then multi-level feedback queue. There are two. I told you that this queue is not a single queue, but it is a collection of queues. And every queue would have its priority. So this is queue number 1, queue number 2, queue number 3, queue number 4. Remember, no matter how important task the computer is performing, remember, no matter how important task the computer is performing, if there is an interrupt, computer should know about it. Okay? So interrupts priority is highest. Out of all these queues, there is a possibility that every queue would have a different policy implemented, but these queue would have their own priority as well. So these are, let's say, in this ready state, there are 4 queues. The first queue should be having interrupt in it, and the interrupts policy is always first come, first serve. And then you may have shortage of first, shortest remaining time, round robin, different policies implemented over different queues. Another type is this. In this type, what happens? The job that goes from its respective queue gets back to the same. Let's say a bank has this deal every day that after 12 a.m. they will back up their server. Whole day there were transactions happening either at ATM or at bank, and at the end of the day, after 12 a.m., the server has to back up. Backup is a batch process. ATM is a real time. ATM transaction is a real time process. What is batch process? All transactions are compiled or collected, and at one given moment they will be processed. In real time, what happens as soon as transaction happens, system is actually completing the transaction. So what I'm trying to tell here, that the priority, if the priority of the batch processing is high and the priority of the ATM transaction is low, what would happen? Let's say if you enter the ATM at 1 a.m. in the morning, you enter your card. Now your ATM machine is waiting for the response of server, and server is busy backing up. and the priority of the backup is higher, you will not be able to take your card back until the server finishes its backup and replies. You are waiting. In that case, what would happen? That we will place ATM real-time online transaction in higher queue and backup in the lower queue. So let's say there is no interrupt, there is no real-time transaction, and backup is happening. The backup is working. As soon as you come and you insert your card, there is an interrupt for the priority of your transaction because your transaction is in higher queue. So this backup will be called back and you will be replied first. Once you are done, this queue gets emptied again and the job beneath that queue is of backup will be called back and backup continues. Is it understood? Second multi-level feedback queue is that when the job enters the system, it goes to the first queue, gets executed, when comes back, goes to the lower queue, and then when its priority comes up, it gets executed a little and goes to the lower queue. And ultimately it gets down to the lowest queue and then round robin happens. Depends at what sort of work you are doing. Setting priority is not your criteria. It is operating system's criteria according to these policies. Sometimes you may be asked that what आपको situation दे दी जाएगी and you will be asked that what sort of policies should be implemented. Then you would have to decide that otherwise it is the operating system's job. You don't have to actually uh, care for it. All you need to know is you should know what are objectives. You have to learn those objectives. What are criteria? You would have to learn those criteria and how these criteria are implemented using algorithms or policies. And you would have to then tell that what are policies. There are two types of policies: preemptive and non-preemptive. Preemptive policies are those where job may get given. The job may leave the processor and get back to the ready queue. And non-preemptive is when the job gets to the processor, it would only leave once it is finished. Is it understood? All right. There is one criteria called processor bound or IO bound. There are a number of questions which are asked for this criteria, that which job has more priority, IO bound job or processor bound job. Having processor bound job given the highest priority will be like giving a thief your home and asking to guard your home by saying यार थोड़ा ख्याल करना मैं आ रहा हूँ 2-3 दिनों में. If a job is by nature processor bound and you are giving it priority, never leave the processor. All rest of the jobs will wait then. And wait until what? Until the processor finishes its work. So we never give priority to processor bound. We give priority to IO bound jobs. IO bound job use less processor and more IO. So they are not using processor anyway. In that case, let's say if this job, this is processor, these are tasks and this is processor time. In a processor bound job, when it is working, it is not allowing other jobs to work. But if you give priority to IO bound job, it would do a little processor time. It will use a little processor time and rest of the time it will be spending doing IO. While the IO is happening, the other processor bound job is actually utilizing the processor. Overall, we get this multitasking done and without any notice. We don't notice. So Those jobs which use more processor time and less input output are processor bound, like mathematical calculation and stats. Those jobs that use more input output and less processor time are called IO bound. And we should give priority to IO bound jobs so that all of the jobs can work. If we give priority to processor bound, it will eat up the processor time. It would not leave it until it is finished, or it will allow only little time for other jobs when they are busy themselves doing IO. Processor bound job, whatever it is, processor bound or IO bound, they need a little IO as well. Okay. Let's see what we have covered. Concept of multitasking in process, the process states running ready and blocked, the need of scheduling, the concept of an interrupt while scheduling. All right. Okay. How the kernel of operating system. What is kernel? The part of the operating system which is always loaded in computer's memory so that it could look after the whole operation of computer. That part, there is a war between all these operating system manufacturers all over the world, is actually very necessary. And if it is complicated, it is bigger in size and eating up a lot of main memory. So there is a war between all these software manufacturers who are trying to reduce the size of the operating system part, which is always in the memory, so that more space could be found in computer's main memory for other programs. So what is kernel? Kernel is the part of operating system which is always there, loaded, executing, looking after, controlling whatever is going on. The scheduling is also a task done by kernel. So it says how the kernel of operating system acts as interrupt handler and how interrupt handled is used to manage low level scheduling. So this is all completely, let's say it means that whenever there is an interrupt, operating system generates an interrupt so that the job could move between states. That's it. You don't have to study more about it. Overall, you get the idea. We have got objectives. Objectives are met using criteria. Criteria are met using policies. Policies are also algorithms, and these policies are only for high-level scheduler. And when high-level scheduler works, when the job enters the system or job gets back from the processor to the ready state. While the jobs are moving in between the states, it is actually because of the interrupts. Interrupts are being generated by kernel. Okay, and that's it. Jobs are being moved between the states using low level schedule. Is it understood properly? So let's jump to the second part that says show understanding of paging, memory management technique. I told you that multitasking also means that your system is actually holding up so many uh, jobs together in the computer memory, main memories. All these jobs are piled up. They are managed inside the memory as you are sitting in this class on your respective seat, and there is no hurdle occupying that much space. It used to be a time when one of the program in computer's main memory used to jump into another program's main memory, and I don't know if you do remember, it is used to be called blue screen of death. Whenever one program access another program's memory or eats up another program's memory, system is halted, system is hanged, and it does not go any further. Nowadays it is not common, not I have not seen it for so many years now. So it is the duty of operating system to keep all these jobs separate in computer's main memory, and there are so many techniques implemented. There are so many techniques implemented. One of the technique is called paging. Paging is used by operating system Windows and related. All Linux based systems are not using paging. They are rather using another technique called segmentation. All right. So segmentation used to be the part of your syllabus. Now it is taken out since 2015. So we are going to study what? Paging. I've got a question I made for um, a mock or midterm. I'll solve that question for you.